In this video, we'll get some practice with queries, resolution, and get a look at the tree structure that the resolution algorithm creates. So in the provided code, you should see a coffee.pl knowledge base that represents some bookkeeping information about a fictional coffee club. So we have 3 managers here, Mary, John, and Bob, a number of bills that were delivered. So the bill says manager received bill with the ID that was worth some amount. So they received the first receipt that was worth $14. That went to John. And then down here is whether or not these bills were paid. So John, in this case, paid $15 for the first bill. Mary, as it were, paid $20 of the second bill. The third bill got paid $12. The fifth bill, $17. And the fourth bill, and 6 through 8, all remain unpaid. Okay, so let's start with some easy queries here. An easy one like, is Bob a manager? So if we want to know, is Bob a manager? That's pretty straightforward. We go to our query here. And before I start this, I want to highlight that, again, you should pause these videos, try to work these out in advance, and then see the answers. So is Bob a manager? If we want to know that, we can ask our knowledge base, is there a manager such that the name is Bob? And that's true. Okay, so just manager Bob. Now, if we want to know who is a manager, rather than providing an atom, we can provide a variable. So manager, say who, or you can say name or X. And that's true if that variable is Mary, if it's John, or if it's Bob. So we could say manager X. Let's just do that. So as long as this is an empty variable, it will unify with the various terms in here. All right, next we have what bills have been paid. So in this case, we're not looking for what bills exist that don't have a paid amount. We're just looking for which bills show up with this paid relation. So we can actually just ask paid ID, and we don't even care how much they were paid, just what bills have had some money paid toward them. So we can put a don't care variable in there. So bill 1, 2, 3, 5. And if we want to know the amount, we can pass in bill paid and amount, and we'll get 1 for 15. Oh, sorry. 1 for 15, 2 for 20, 3 for 12, 5 for 17. All right. So pretty straightforward for all of that. Now, if we want to get specific information, like how much was bill number 2 worth, then we could just ask a query along the lines of bill, provide the information that we do have, like bill number 2. So we don't know who the ID is, or sorry, who the manager is that paid it or that received it, but the question doesn't ask that, so we don't care about that. So just underscore that. We know that the ID is 2, because bill number 2 is the one we're asking about, and we want to know how much was it worth, so we can put the amount, or perhaps more specifically, the cost. And there you go. The bill 2 was cost the coffee club rather $25. Okay. Did Mary pay bill 3? Now that's a bit more of a involved query. Did Mary pay bill 3? Asks, is there a bill 3 that went to Mary? And was it paid, right? There's 2 kind of parts there. So first off, bill for Mary number 3. We don't actually care about the cost. It doesn't say did she pay all of it. Just did she pay toward it, I suppose. Billed Mary 3 and then paid 3. So this is one way of asking that. Did the bill go to Mary, and did Mary pay it? Was it paid? And in that case, that means Mary paid that bill. If we also want to know that the whole thing was paid, paid through, like it went through, we could say bill Mary 3 for cost and paid 3 amount. So we find out how much was paid, how much was it cost, and then was the amount greater than, so the amount paid, was that greater than or equal to the cost? So was the bill actually paid off as opposed to just being paid? And that's true because paid 12 here, bill was 12 here, and as this didn't return false, it says true on the condition that cost and amount were both 12. Or in the result, I guess you could say, that cost and amount are both 12. All right, so that's a few different possible answers. We'll take both of them in our results here. So that's true, and percent query dash, there we go, that one. All right. So the next one we have here is which managers have been sent a bill for less than $10? This is a bit of a bigger query. There's a few different potential answers you could come up with, but I'm going to write one that's maybe not the most efficient expression. So which managers have been sent a bill for less than $10? So we want to know, first off, what managers there are, what bills went to that manager, and then was that bill worth less than $10? So let's start with manager name. So does there exist some manager by some name? And if so, was there a bill to that person? So notice we're using the same variable name here and here. So once this succeeds, it will be bound to an actual manager's name like Alice, Bob, or John. And then bill here will have bill for that specific manager. So bill name, we don't particularly care about the ID in this case because it doesn't say which bills, just which managers received bills. So manager name, bill name, and then the amount. So we do care about how much that bill cost us. And then we should say for less than $10. So amount is less than 10. This will give us a bunch of answers, so let's actually see the answers here. But I want to talk about this in a bit more detail as well. So if the manager's name is John and amount is 7, then that's one of them. Another one is John's 5 and John 2. Might actually be more instructive just for the outputs here if we do include the ID as well. So let's walk through this again. John received bill 5 for $7, bill 6 for $5, and bill 8 for 2. And then Bob received one bill for $4. Now, I want to walk through this one and see how this is searching through this tree to find all of these answers, because bill 5 is not the very first bill here, right? Bill 5 is way down here. So why is that the first one that it came to? And specifically, why does it show up before our answer for Bob's bill here, right? Bob's bill 4, which also shows up in our answer, shows up last in this case. Now, as I mentioned, these things search top down, so let's take a look at what's known as the resolution tree, or the SLD tree, as they're technically called, for this query. Let's minimize all this stuff and bring up a whiteboard here. So the initial query looks something like this. We had question mark manager name, then we had bill for that name with some ID and some amount, and then amount is less than 10. So this was the original query that we passed to our resolution algorithm. So we have 3 sub-goals that need to be satisfied, and if we match to any rules, as if it were possible, then this could grow as well. Now in this case, our knowledge base, let's get this to the side if we can. Our knowledge base here involves having only facts. So this tree should only shrink, or this resolution goal should only shrink. But what happens is it goes to the first sub-goal first. So it says, try to satisfy this first. So manager name. So it goes to our knowledge base and says, is there a manager of some name? So sure enough, there is a manager Mary. So we can say this is true if we have name equals Mary. I'm still kind of new to this whiteboard tech here. All right, so name equals Mary, and then our goal becomes something a little bit smaller. So if if name is Mary, then our new goal is bill for Mary, ID amount, and amount is less than 10. Sorry, I should probably also put in our query delimiter here as well. Okay, so now we're trying to satisfy these 2 sub-goals, the remaining sub-goals, but we have this one binding here that name has the value Mary. So in our bill now, we're saying bills specifically for Mary that are under $10. Okay, so does that unify with something in our knowledge base? Well, we come down here, here's a bill for Mary. So bill matches bill, ARD 3, Mary matches Mary, 2 goes into ID, and amount gets the value 25. So that's great. So our query is satisfied there. with ID equals 2 and amount equals 25. Just put that there. Okay. And then we're with an even simpler subgoal now. We have amount less than 10, but amount, as we just saw, has the value 25. So our goal now is 25 less than 10? That doesn't go to the knowledge base because it's just a comparison operation, but that's patently false, right? 25 is not a smaller number than 10, so that doesn't work. So what happens then, if we fail to evaluate or fail to resolve one of these subgoals, what we have to do then is backtrack. So we go back up to this one here. We undo these two bindings, and now we're back at this query here saying, is there a different way we could have satisfied this? So instead of saying Mary got bill 2 for $25, it continues the search and says, well, that can also unify here, right? We have bill, arity 3, Mary, ID gets 3, and amount gets 12. So this could be true if we have ID equals 3 and amount equals 12. Okay, and then our query is a little bit simpler again. We're down to just the comparison. 12 is less than 10. That obviously, though, is again false. So that doesn't work either. So we backtrack. This doesn't work. And we go back up to try and satisfy this step again. So we go looking through the knowledge base. Is there something else that can unify with this expression? Bill, Mary, ID, amount. So bill with arity 3, sure, but nothing else that has Mary as the first term. So that means is we can no longer satisfy this subgoal. It's no longer provable to be true. So what we do is we backtrack again. We end up back up here, and we undo this binding. Okay, so we undo that unification, and now we're left to say, can we satisfy our original query in a different way? So that first subgoal was manager name, so can we find a different manager? So we come over here with name equals, and the next manager down is John. So that's just from we just satisfied that one, or we attempted to satisfy using manager Mary. That doesn't work, so we backtrack and we try resolving using John. Right, so our query is similar to before. We get bill for John at some ID and some amount, such that that amount is less than 10. Cool. So will that unify with something? Well, sure enough, we can find something that unifies with bill, John, ID, amount. In our knowledge base, we have bill, John, where ID is 1 and amount is 14. So another arrow down. Oof, that was a bad arrow. I'm just going to try that one again. There we go. Another arrow down here. We have there's space there. ID equals 1 and amount equals 14. Okay. So then our query, so we said, yeah, we can unify that, so our query gets a little bit simpler. And now we just have to say, is amount less than 10, where amount is 14? Well, again, that doesn't work, so we backtrack. So we undo these unifications, and we're left at this step of our search. Is there a different way we could satisfy bill, John, ID, amount? So we go looking through our knowledge base. We tried this one, so we go on down. Here's another bill, John, that has ID 5 and amount 7. So if we get, I'm just going to type this first so I know how much room I need. ID equals 5 and amount equals 7. And then draw an arrow here. Sort of good enough. Then we have our new query is amount less than 10? Amount is 7, so is 7 less than 10? Suddenly it is, right? So now what's left, if we go any further, oops, is an empty query. And if you ever get to a point where our query is null, that means we've succeeded. We've gotten through all the sub-goals. We managed to resolve each one of those, so there's no more sub-goals to prove, so the whole thing was proven, and we'll return the unifier that we created along that path. So name equals John, ID equals 5, and amount equals 7. And if we go back to our Prolog search, that's exactly the first one that we get. Name is John, ID is 5, and amount is 7. Now, if we hit the semicolon like we did here, we can force it to backtrack and say, okay, what happens if we don't like this? So backtrack, find a different way of satisfying that. Excuse me. Find a different way of satisfying this result here. And we have up here John 6.5. That one will also work. John 7:15 won't, but John 8:2 will. Sounds like I'm reading Bible verses now. And if we keep backtracking, eventually it will say, okay, there's no other ways that John got a bill for less than 10, so it'll go all the way back to this first rule and say, what if we look for a different manager? The next manager is Bob, and then Bob's bill will show up. And notice that's why Bob shows up last in our result here, because it's going manager by manager, because the first query here was looking for a manager of a specific name. Then all of these bills have that manager name bound. So it starts with all the Mary bills, then all the John bills, and then finally the Bob bill. Now, if we had removed this, it's a bit superfluous for this query, because we can get the name from the bill itself. If we assume bills only go to managers, then it's not really an issue. We don't need this first bit. Then it's actually going to resolve through each one of the bills in turn. So we'll see John 1:14, that will fail. These two Marys will fail, and then Bob will actually be the first one that succeeds, and then John, and then John, and then John. So yeah, the order of these of our queries is going to control the search through our tree. And you can see, yeah, the resolution itself forms a depth-first traversal through the knowledge space, if you want to call it that. So it creates this tree that if any branch of that tree ends in null, then we have success. And if we can't ever find a null branch, so say a terminal branch like we found here, then eventually we'll backtrack to the point where we can't find another way we could have answered this query, right? Like if we had asked, is there one where the amount equals 0? It would have gone through and found none of these matched 0, so then it would have failed and the entire thing would return false. All right, so with this resolution tree in mind, let's do a couple more queries here. So let's get everything back in place. So we need this to the left, Prolog up on the screen, and then did we copy that down? Bill less than $10, let's copy that down as well. Okay. So who has been sent more than one bill? So if we want to know who was sent more than one bill, we have to ask who was sent one bill, and then ask who was sent a second bill, and then ensure that those two bills are in fact different. So we could say bill for some name. We're going to want to keep track of the IDs to make sure that it's different bills, as we'll see. But we don't really care about the amounts in this case. It doesn't say who was sent more than one bill for $10. We just care that they had any bill at all. So name got bill ID, and then we're going to take another bill for the same person, so the same variable name, but a different variable for ID. Okay, and we still don't care about the amount, so that's also an underscore. And now one last thing, we have to make very sure that these two variables, ID and ID2, don't have the same value, right? We want name to have the same value as name, and that's controlled by using the same variable. But if we use two different variables, they might be the same, they might be different. We saw that with Alice being friends in the previous lecture video. So what we want to do is add one other query or one other clause to this query and say ID does not equal ID2. So in this case, let's walk through how this will resolve a little bit. So this first one says find a bill. Basically any bill will do, right? We have variable, variable, don't care variable. So anything that matches bill. So it's going to grab this first one. And then it'll find another bill for name and ID2. And again, pretty much anything will go, except when we unified here, what we have is name now equals John, ID equals 1, and this don't care variable got 14, but we don't care about that. So when we come to query this second bill, name now has the value John. ID2 is a brand new variable, so it has no value, but name got unified from the previous step. So this will unify with this first line as well, though, where John 1 and 14. So ID 1 equals 1 and ID 2 equals 1. Then our last step here will say, well, 1 equals 1, so this is false, asking if these two things are different. So it'll backtrack and it'll say, well, is there a different bill for John that isn't 1? So it'll search on and says, well, here's a bill for John, 5. So ID 2 is now 5, 1 does not equal 5, so we get our answer. Now, if we continue backtracking, it's going to keep resatisfying this second query as often as it can. So backtrack, backtrack, and backtrack. We get all of John's bills. Now, if we backtrack one more time, there's no other second bills for John, so there's no other ways to resolve this second subgoal. So what it'll do is it'll backtrack to resolving this first subgoal and say, is there any other way we could satisfy that? So we backtrack again, and now all of a sudden we're talking about Mary's bills, because that's the second one in that search. So Mary, that'll unify with that, and the second bill in our goal will unify with the next Mary, and we get 2 and 3. Now there's no other secondary bills for Mary, so it'll backtrack again and start reversing everything. So the first bill here, a third option for that first bill would be to use this third bill here. And then going through the search from the top of our knowledge base for a secondary bill where name is Mary, we'll land on this one here. We get the reverse of the first Mary result. Right, and then we're getting all the reverse of all of these other results as well. 5, 1, 5, 6, all the possible pairs of bills. So we're getting a lot of answers here. But the main point, coming back up to here, this here, any bills for, or who has been sent more than one bill. There you go. We can see those different bills right there. Now, on an assignment, for example, if I ask you for pairs of things to create a query that returns 2 pairs of things, if it ends up resulting like this, that's fine. As long as it gets you the correct answers, if it duplicates those answers in reverse, that's just how Prolog do. All right, let's do the next one here. So who has made a payment less than the amount of their bill? I believe we kind of already seen this query a little bit, but let's walk through this one as well. So who's made a payment? So here's our paid results here. Who's made a payment for an amount less than the cost of their bill? So we have to do a few things here. We need to figure out what bills exist that were paid such that that payment was less than the amount. Okay, so we have bill for some name, because it does ask who. Bill for some name. It doesn't really care about the ID, but we're going to need that to match things. And we need the amount in order to figure out how much was paid of it. So we need all of these values. And then we want to know, was this specific bill, the bill that we just found by querying, right? Think if I just queried as it were here, we get all the possible bills. Stop there. But so now that's going to unify with the first one. And then we want to see, was that bill paid? So ID 1. Now we need to see paid 1. So paid ID, so the same variable that has a value now, and then we'll get the amount that they paid. I'm actually going to change this variable name here to cost. So bill for a cost, paid some amount. And now we need to know, was the amount paid, sorry, was it less than? Less than the amount of their bill. So was the amount paid less than cost? So who still owes money on one of their bills? And that's true of Mary. On bill 2, the cost was 25. She's currently only paid 20. We backtrack, no other possible bills. Now notice it was waiting to see, is there something else? Because by the time it found that that Mary was in there, it had, well, let's just go back to our tree for a second here. It had constructed some tree, and I'm not going to walk through the potential of the tree that it could have constructed here, but it constructed some tree, and there was a point where it made a decision, like a decision point here, to say, name is John, for example. It could have backtracked and gone on to found other potential values, for example, Bob, but maybe Bob isn't delinquent in any of his bill paying, so when it did that backtracking, it found that there was no null paths, so to speak, no empty branches. So it gave me the option to backtrack, but then when I did, it returned false. All right, so who has paid a bill less than their amount is this. Let's go back to our line here. Who has made a payment less than their amount? Okay. Who has received a bill but not paid it at all? This one's a little bit similar. The only issue is we can't query for paid and then say amount equals 0, for example, because that information isn't in our knowledge base. If somebody hasn't paid something, it just simply doesn't show up, which is to say we can try to prove that they did pay it, and when that fails, make it true by flipping the condition with a not. So we'll say, is there a bill for some person? We'll need the ID to match it to the paid. We don't really care about the cost. Okay. And then we want to know if this thing was paid, and that's not what we're interested in here, but I'm just going to type it like this. If this thing was paid, that's great. So ID Again, we don't care about how much was paid. But what we're asking now instead is, was it not paid, right? Is there a bill that exists that was not paid? So we'll just take this last term here and wrap it in the negative. So this bill exists because we matched it with this first clause. And then it says, if I can prove that it's paid, I'm going to return false. But if I can't prove that it's paid, so this would be false, then not will return true, because we're asking who has received a bill but not paid. Okay, so ID 4 doesn't show up in our paid, so that's one of them. And if we backtrack, we can see 6, 7, 8 also have not been paid. Okay. Now, what is the largest bill given to John? Now, this is probably one of the trickiest queries to answer in Prolog. What is the largest? You could try using max and min, but those generally only work for lists, and we haven't learned about lists, nor have we learned a simple way to turn facts into lists. So what we're going to have to do now is think of a different way of asking this query. Where is that query? There it is. So a different way of saying what's the largest is to say, is there such a thing such that no other thing is bigger? Okay, so we're going to look for something in our knowledge base and then try to prove that nothing in our knowledge base is bigger than that thing. So we're going to use the not form here as well, but we're going to have to do it a little bit more involved. So what is the largest bill given to John? So a bill given to John, let's just take the ID. I don't think we need it, but we do need the amount because it's asking what's the largest amount. Let's call it cost to be consistent. So the largest cost bill that was given to John. Now what we want to say next is there any other bill that was greater, right? If so, then this is going to be false. So we'll take that and we'll flip it with a not to say that there's no other bill that was greater. So not another bill. I'm going to put double brackets here. I'll explain that later. Is there another bill for John specifically? Again, don't really care about the ID. I'm just going to leave this as ID 2, such that cost 2, different variable, and that cost is greater. So cost 2 is greater than our original cost. Okay, so this is the bill that we found. So that'll be the first bill here, John 1:14. And then it's going to say, is there not another bill such that this other bill has a greater cost? If there is, then this inner blue part will be true, which will make the whole thing false, which means this is not the largest bill. Now, if this happens to be the largest bill, then cost is the greatest. Then we'll try and prove this. So we'll find another bill where the cost 2 is greater. We won't be able to because we've found the biggest one so far, so this should be the largest value. So this will give us false for all of the other bills that we can find, which means this whole thing here should be false, and then we'll flip that to make it true because we want to find the largest. All right, now the double bracket here is because not is actually an arity 1 or a unary operator. And we want to not the entire result of this blue thing, not just the single. So if I remove this, oh, hang on, I have to keyboard over. If I remove this inner bracket, now this is essentially asking not to be an arity 2 predicate, right? Because it's here's the first term, there's the second term. But not only takes in one arity or one term. So if I wrap this in a bracket, then this is essentially saying resolve this inner bracket first down to a single term, true or false, and then not whatever that is. So flip the expression. All right, so the biggest bill that John ever got, we can do by I here, is 15. So we should get ID 7 and value 15. And there you go. And we can try to backtrack, but there's not going to be a larger one because there can only be one larger one. All right, so again, in order to find out who has the largest of something, find something and then show that nothing else can be larger. Similarly, if we want to find the smallest, so then actually let's copy this down because the next question is about the smallest. So let's copy this one. If we want to find the smallest, who was given the smallest bill, so this isn't the smallest bill for John specifically, it's who out of anybody. So we could say find a bill for someone. We want their name in the end. We didn't really care about the ID, but Let's keep it. It's useful information to see which bill it was, and the cost. And now we want to find the smallest bill, so it's pretty much the same thing. So not, is there a bill for that same, or for anyone rather, it doesn't matter for the same person anymore. So of all the people who was given the smallest bill, we don't care about the ID either, but we do care about the amount of this other bill. We'll call it cost 2. So there's not some other bill to any other person, any other bill here, we don't care. There's not some other bill that's smaller, so cost 2 is less than cost. Okay, so if we find this bill, we're going to then show that there's no other bill that has a smaller cost. There's not some other bill with a cost less than this bill. Run that, and there you go. The smallest bill was cost 2, and that was sent to John, and we can quickly verify that manually. Now, one last thing I want to point out about these queries. If they're very useful queries, let's say if you want to run them multiple times, it might be useful to also create a rule for them. So we could turn this into a rule, for example, quite straightforwardly, just by saying, what do we want to call this? Smallest bill. Smallest bill for some manager. Okay. And then we turn that into a rule by then just taking the query that we use to satisfy that as the body of this rule. Now we passed in manager, not name, so I'll say manager. Okay. Yeah. That's pretty much it. So it's going to be smallest, so it's going to be less than, and that's pretty much everything there. So now we just have a rule that does the same thing, and if we requery coffee here, coffee query, singleton variable ID, because we're not actually using it here, so we can get rid of that. Try again. Now we can say, what is the smallest bill for any manager? Just pass in name here. John got the smallest bill, and we can say, did John get the smallest bill? Or let's ask, did Bob get the smallest bill? And that's false. Now, if we also want that cost, we can pass that in as well. So we could say manager, comma, let's just pass in the ID. It'll make it easier. It's about the same, actually. So we can ask then, what is the smallest bill of anybody, and what was its ID? Leave both of those empty, and we'll get a value. Oh, it helps if I actually reconsult the knowledge base. There we go. So this will unify with the head of our rule, where we have two unbound variables here, name and ID, and then it just satisfies this the same way it satisfied the query. So it finds a value for bill, and then says, is there not a smaller value? If there is, it'll backtrack and find a different value for bill, and then ask again, is there not a smaller value? If it can't prove that there's a smaller value, then it succeeds, and the unification that we made here with manager to John and ID to 8 gets passed into the variables that we unified. So name to manager and ID to ID. Okay, so then manager gets John and ID gets 8. So name gets John and ID gets 8. So you can think of those as return variables in a similar way to how when we're querying something and we leave something a variable, it comes back with a value. All right, that's the end of this video. In the next video, we'll go into a more complicated example using more resolution, but to see some of the efficiency considerations that come into play. See you then.